All right. Now let's go back to the Harold's 12s. Okay, yeah, first thing, notice it's now 1 through 5.
Which one do you have?
Are we doing this together?
Yes.
Okay, good.
If you want, yeah, unfortunately, I didn't hand it out, so we're sort of stuck with doing it together.
I'm okay with it.
You don't have that one. Is that what you just said?
Yeah, you don't have that on a handout. But, yeah, so that's an interesting thing. Can we conclude anything about about the 5s? They're not involved in any multiplies, right? I mean, if any of if a 5 is in a multiply row, it's impossible because 5 doesn't divide into 12. Now that doesn't mean some of them aren't multiplies, right? You could have a 3 and a 4. The numbers are 1 through 5, right? So we're going to have at least one 5 in every row and in every column. But wherever those 5s are, it can't be a multiply. Because all of the clues are 12. So you can't have 5 times anything to give you 12. Right.
Because all of the cages are 12.
Right, because all the cages are 12. It's just, I mean, there can certainly be yeah, and some of the cages can certainly be multiplied. It could be 2, 2, 3, or 3, 4, 1, or just 3, 4.
12 is not, 5 is not a factor of 12.
Right. So, can anybody see any way to get started on this?
We got to draw these cages first. There's 2 in the top right corner. There has to be 12. So we have multiplication.
Yeah, I can't add 2 things to give 12, right? Because 5 and 5 isn't even enough. So that upper right corner has to be a 3. It has to be multiply, and it has to be 3 and 4. So this is what? 3 and 4.
I'm sorry.
Well,
The one in the middle? Where? At the top here? Oh, this 12. Okay.
Any time we have 2 squares with a 12, it has to be multiply, and it has to be 3 and 4. So we can do the exact same argument here. What was it? 3, 4, right?
It could be multiple. Which one are you talking about now? Which the one with 12.
Never mind.
Either way, it has to have 3, 4. Yeah. Don't tell me the cage with 12.
Right. No, there's no 6. We only have dots here. Yeah, that's true. Okay, so it could be 2 times 2 times 3. Oh, yeah.
The 12, the second,
Okay,
the second row,
The
the 12 in the middle there.
This one
Yeah,
here?
well, it could either, if you multiply 4, 3, and 1 to get 12, the problem is you already have 4 and 3s in the other ones. So you can't have 4, 3, and 1 there, so it probably has to be addition.
4, 3.
I guess,
I think it would be possible still to have 4, 3, 1 and multiply there, because all we have to do is we've got 4 columns to fit 3 4s, and we've got 4 columns to fit 3 3s. So it could be 4, 3, 1. I don't know for sure that it's not.
If there's 4 things that can't be multiplied.
So like here's a 4. Here's a 4.
Has to be added.
These these have to add, right? I mean, if it's multiplied, the smallest you could have would be 1 times 2 times 3 times 4.
Since they're all in a column.
Yeah, for this one especially. This one, the smallest it could be, if this is a multiply, it would be, the smallest it could possibly be is 1 times, use the smallest numbers you've got, 1 times 2 times 3 times 4. So it's already 24. So this one can't be multiply. This one has to be add. And that's interesting. Oh, did anybody add up the numbers from 1 to 5? 15, okay? We always, right, so the whole thing adds to 15. Here's 12 of them. This has got to be a 3.
I agree.
Row, the 12 to the right has to be addition. Because you've already got
3 and 4. You already have 3 and 4.
Okay. The middle row, this one here?
3 and 4, yeah.
you have to have a 2 and a 1. I guess not. Forget that.
Okay, oh, you said you had a stronger argument. Well, can we could have multiplication for 4, right? But this one,
You can have 1 times 2 times 2 times 3.
you can have 2 1s, right? 1, 1, 3, 4, right? Because we've got different rows and columns, we get a lot more possibilities. And you could actually cram a couple of 1s in here, or you could have 2, 2, 3, 1. There are a lot of ways that this could be multiply.
Right, it was just, I stated it too strongly.
Yeah. It works here, though. It's great here because you've got a lot of constraints. We know we have to... How about this one? I mean, this could be 1 times 2 times 3. You could do it. This could be a multiply 2, right?
Yeah.
1, 2, 3 is 6, and then another 2 up here someplace. So it could be 2, 1, 3, 2. That would be a legal thing to have a multiply 12 if you wanted.
Okay, so you know that the first and third from the first column has to be a 1 or a 2. It can't be a 3 or 4. So the top
row,
that has to be a 1 or 2, and then the third one also has to be a 1 or a 2.
It could be a 5. It could be
It'll
a
be
5.
5.
We know. We know
It
we've
could
got
be.
1, 2, 5.
You're right. You're right.
But you have to use a 5 in that L-shaped one, because if it was a 1 and a 2 in there, you could get a 9 or a 6.
Yeah. Okay. Great observation.
Right.
We've got a 1, 2, and 5. These two things have to be chosen from among 1, 2, and 5. If the 5 isn't there, then we've only got a 1 and a 2, and we'll need a 6 to multiply, or we need a 9 to add, and those are too big. So this can't be a 1 and a 2. So there has to be a 5 in here somewhere. Okay, so that means this one is either a 1 or a 2. This is a 1 or a 2, and I'll just say 1, 2, 5, 1, 2, 5, at least for now.